Welcome back. This is an Aleks training video on writing a solubility product, which is KSP expression. No math here, just writing an expression. In fact, we've actually already done this. I think you'll find it fine. Solubility product expression, KSP, has to do with when something is saturated. If you dissolve sugar in iced tea and you end up with an inch of sugar at the bottom of your cup, all of the sugar that the water can hold is dissolved, and then the rest that you put in the cup can't dissolve, so it falls to the bottom. It is in equilibrium, which means that some of that crystal is dissolving into the water at the same rate that the sugar that the water is holding is letting go of it, and it recrystallizes and falls to the bottom. So even though there's the same amount of sugar at the bottom, it's continuously different sugar because it's in equilibrium. The equilibrium constant, your K sub SP, is telling you how much is soluble. So when you look at the K sub SP and you have a very small number, like a 10 to the negative something, then you know that very little of that stuff will dissolve in water. If you have a huge K sub SP, that means that a ton of it will dissolve in water, or all of it, depending. You know that there are certain things you can stir in, like your chocolate milk. You stir in the chocolate milk and it dissolves. If you were to accidentally put cocoa in your chocolate milk, that cocoa has so much oil in it, it would float to the top of the water. It wouldn't dissolve at all. It would have a very low K sub SP, but like Hershey's Quick or Nestle's Quick or whatever it is, would have a very high K sub SP. We're going to ignore the zinc carbonate itself because it's a solid, so we're only interested in the aqueous parts, the ones that are actually in, that are turning back and forth between crystals and solution. So that means that our K sub SP is going to be a product, and that's why it's called a solubility product. That's the SP, solubility product. It's the product of the concentrations of whatever you've got raised to the coefficient of the balanced equation. So I've got zinc here, that's a 1. I've got carbonate here, that's a 1. That means these guys are going to be to the first power. If this were a 2 or a 3, then you would have a square or a cubed for the zinc here. So I just want zinc, and so it's the zinc ion, so it's zinc and the carbonate, CO3, 2 negative, and that's the expression. So you find the concentrations of those, multiply them together, and then you have the K sub SP. So pretty simple.